Hi everyone, welcome back to Comp 2160 Programming Practices. We are at the end of week 4. We are now 2/3 of the way through this course. And as usual, I want to just quickly spend some time taking a look at the learning outcomes that we have seen this week as they are in the course syllabus. And yeah, tell you a little bit about how you might expect to be assessed on some of those learning outcomes. So let's take a look. Here's the course syllabus for our course for this week. And a lot of what we spent our time doing this week was looking at testing. And our major learning outcomes were related to generating test data and then using that test data in tests that we have either entered by hand or that we're automating with test harnesses. So the learning outcomes that we saw this week are explain the purpose of testing code. You might expect to be assessed on a learning outcome in general. So in general, if you see the word explain, this is something that you should expect to see on a written assessment. And written assessments in this course are going to be final exam at this point. If we had done this before the term test, I would say it might be reasonable for you to expect to see it on the term test, but in that the only written assessment that we have left is the final exam, I would expect to see something like this on the final exam. Explain the purpose of means give me reasons why we should be doing testing. So what are we trying to accomplish by doing testing? What are we trying to find? What are we trying to prevent from happening going forward in the future? List the classifications of test data, general, edge, and leaks. So here I'm really just looking for you to tell me and then define what each of these things are. Create general and edge case test data. So these two learning outcomes you are being assessed on in the assignment that you are working on right now for assignment 2. You'll also be assessed on these learning outcomes in assignment 3, and you can expect to see these on the final exam. General case test data, remember, is kind of like the stuff that we would expect our parents or other people that we're giving our code to enter into the program that we're working with. And it consists of the outputs that we should expect from that. So given a normal situation where my parents are using my code, they enter a specific value. This is what I would expect them to see. And the big goal with testing here is that we're trying to kind of like pretend to be the person that's actually using our code. So we're no longer thinking about what the programmer's perspective is. We're thinking about what that person that's using our code is going to see when they're working with our code. So general case test data is like what would normally happen if I did the normal thing with the code that I've written as the person that's sitting at the keyboard actually typing stuff. Edge case test data. So I'm expecting you to be able to create both of these different kinds of data. Edge case test data is going to be where it's valid data, but it looks kind of weird. In class, we're looking at this from the context of a string. And what we identified was that there's edge case test data that's valid in some cases and not valid in other cases. So really specifically with char at, we were looking at this idea of the empty string being an edge case. In the char at example, the empty string is an invalid case because asking for the 0th element of something that has 0 elements, it doesn't have any items in it. Asking for an element from something that has no items in it isn't a valid request to make. Our code should handle this in the form of the defensive programming, and in other weeks we've seen this be able to write code safely in a programming language that doesn't allow safe, makes it easy to write unsafe code. Our code should handle those cases, but this is invalid data. This is not something that we would expect a regular person to be able to enter in the first place. So in the case of char at, our edge case data was a single character string, one that has just one character. In other cases, like if we were asking for the length of a string, an edge case might be the empty string. It's perfectly reasonable to have a string that has no characters in it and then ask for how long is this string, and we should find out that it's 0 characters long. Explain the purpose of automated testing. So we've got two very similar learning outcomes here. One is explain the purpose of testing code, and this is just in general. Explain the purpose of automated testing. Again, this is an explain outcome. So here I'm looking for you to tell me about why we're doing this thing. And ultimately, the purpose of doing this automated testing is that if I did manual testing constantly, it would just take forever. And automating that, we are programmers, we're computer scientists, we can write some code to automate tedious work. So let's write some code to automate the tedious work of testing. So we're going through the process of creating these test cases. We're implementing test harnesses, so that's the next learning outcome, and then we're running those every time we're making changes to our code. I'm going to go back because I missed this, manually test an ADT with test data. So this is where we're going through the process of really the process where we're reading from standard input test cases and then evaluating the behavior based on that. So we've kind of done that in assignment 1 already. We're kind of doing that in assignment 2 in the form of we've got an implementation of our bracket matching algorithm, and we're taking input on standard input to have test cases and see what the output of those things are. The last one here, again, implement a test harness. This is where I'm expecting you to write code to encode all of the test case data that you have come up with for general and edge cases. Test harnesses are, I mean, they are code, but they're code that's like, doesn't have to be great, solid, high quality code because it's something that's assessing the great, solid, high quality code that you've written for implementing something. So these test harnesses, they don't look like great code because they don't have to look like great code, but then they also do weird things like really just hard code a bunch of data in them. And the hard coded data is the general and edge case test data that we've got. The other things that we did this week were related to tools. So we did use a source level debugger such as LLDB to inspect program state and step through code line by line to determine causes of errors in a program. I'm not going to assess you on this on the final exam. I'm not going to ask you to use LLDB on the final exam. This is something that you're being implicitly assessed on in that you are going to probably want to use this as you're working through an assignment. I'm really going to strongly suggest that you take some time to try using LLDB. If you didn't get a chance for assignment 2, try using it with your implementation for assignment 2. It's going to be valuable when you're getting ahead into assignment 3, and it's going to be valuable in general in terms of learning how to use a debugger, a source level debugger to help you with debugging code problems. We've also got these two learning outcomes here. Use an automated build tool such as make, along with a predefined make file to build a complex project. So I gave you a make file. We did talk a little bit about make in terms of what makes a make file, haha, pun intended. We talked a little bit about that, but the goal here really is here, have a make file, and this make file builds something that consists of more than one file. Define the build of their own project by modifying an existing make file. This is the one that I am going to assess you on, and the way that I'm going to assess you on this is in assignment 3. I'm going to expect that the code that you submit for assignment 3 will have a make file along with it. But in the sense that the learning outcome just above that, use an automated build tool with a predefined make file, and then this one specifically says by modifying an existing make file, I'm giving you permission to take the make file that I gave to you and then just modify it to make it work with the code that you've got. You don't necessarily need to come up with one from scratch. You can start with the one that I've given you and use that as a basis for the code that you're writing. The other learning outcome that we did revisit once this week, this was yesterday, was define the implementation of an ADT with a private data structure. And the specific thing that we did there was taking a look at the static keyword in C and how we can use the static keyword to prevent outside code from interacting with things that we deem to be private in our implementation of a data structure, specifically functions. So the example that we saw there was we were able to call the invariant in our string implementation from the main code, even though it's not declared in the interface that we've defined. It's not part of the public interface. I don't really want you to be able to call my invariant, not necessarily because I don't want you as the person using my library to be able to call my invariant. Not because it's necessarily a bad thing, I just don't want you, the person using my code, to depend on the implementation details, the private implementation details. I want to be able to make changes to my invariant that may include things like adding arguments or parameters or changing the name of the function. So I'm going to use this static access modifier to prevent you from using my private implementation details. You will be assessed on that in assignment 3. Any functions that you define that are not part of the public interface should be marked private using the static access modifier. If you do programming questions on the final exam, which you should expect to do, if anything that's defined as private or anything that should be considered private, private implementation detail for that thing should be marked as static. You should be using that static access modifier. We also saw how we could use static to retain state across function calls, but that's not really the purpose of what talking about static. The purpose of talking about static is very much this learning outcome, be able to define the implementation of an ADT with a private data structure. So that's the set of learning outcomes that we discussed this week. Next week is going to be hopefully a little bit less hectic for us in terms of this course. We don't actually have anything due. We don't have any tests. We will have an assignment published on Monday, but it's not due until the last day of classes. Other than that, I hope that you have a great weekend, and I will see you on Monday. Bye, everyone.